Welcome to the Deep Dive AI Brief, episode 319.
Glad to be here.
Today, we're really digging into three big shifts happening right now.
Yeah, it feels like everything's moving fast. We've got the huge speed up in AI infrastructure.
Right, then there's this big push to make AI tools accessible, like, globally.
And underpinning it all is this. Well, this kind of tricky economic situation the world's balancing on, really banking on AI's success.
Totally. And maybe the most striking visual of that acceleration lately is in robotics.
Oh, you mean the XPENG robot, Iron?
Exactly. It walks so well, so human-like.
In fact, people thought it was fake. The company actually had to put out another video proving it wasn't just someone in a robot suit.
It's wild, isn't it? We're hitting that point where robots are getting too good at moving, bumping right into that uncanny valley idea, but for motion, not just looks.
Yeah, it really changes the game.
So that sets the stage for our deep dive from these almost unnervingly real robots to the slightly unnerving economic picture.
Our mission today is to connect those dots. Let's start with the foundation, the hardware. Google's making some massive moves here with custom silicon.
They just announced new AI computing setups using their own Axion CPUs and the 7th gen Ironwood TPUs.
That's right. And, for anyone leading a business, this is the stuff that matters now. It's about raw competitive power.
So what kind of power are we talking about? Give us the specs.
Okay, so Ironwood delivers 4,614 FP8 TFLOPS, that's floating point operations per second, a measure of speed. And it packs 192 gigabytes of this super fast HBM3E memory.
192 gigs of HBM3E? Wow. That's a ton of fast memory right next to the chip.
Exactly. It's crucial for the huge models today. You need that memory bandwidth to keep the processor fed. Doesn't matter how fast the chip is if it's starved for data.
And it scales up too, right? These aren't just single chips.
Oh, yeah. They build these into pods. You can scale up to 9,216 of these accelerators working together.
Okay, hold on. 9,216. What does that get you in total power?
It hits 42.5 FP8 exaflops. Exalog. That's an enormous amount of compute. Enough to train the biggest models way faster than before. Think days, not months.
And it's not just about the TPUs, the AI accelerators. They've got these new Axion CPUs too.
Right, built on ARM's Neoverse V2. Google's claiming up to 50% better performance and, maybe more importantly, up to 60% better energy efficiency compared to standard x86 CPUs.
That efficiency point is huge. It shows everyone, Google, Amazon, Meta, they all feel they need to control the whole stack now, chip design included, to really optimize these massive AI jobs.
It's the only way to get that edge. And it saves money, which matters for them and their customers.
Which explains why companies like Anthropic and Lightrix are already jumping on board. It's about getting results faster, cheaper, more efficiently.
Definitely. So that covers the high end, the massive infrastructure for the big players. But Google's also making a big move at the other end of the spectrum, accessibility.
Ah, you're talking about Opal, their no-code AI builder.
Exactly. They just massively expanded its availability. It went from 15 countries to over 160, basically almost everywhere.
So what does Opal actually let you do if you don't need to code?
Think simple AI apps. You could use it to automate some research tasks, maybe pull insights from data, or generate marketing copy, create interactive stories.
So things small businesses or individuals could actually use without hiring a programmer.
Precisely. It's about validating ideas quickly, too. Maybe build a prototype language learning tool, see if it works, all visually.
That really lowers the barrier.
Yeah.
It democratizes AI app building, potentially disrupting how things normally get built.
For sure. It means innovation can come from anywhere, not just tech hubs.
Okay, but does making it that easy risk just flooding the world with, trivial little apps? Or does it genuinely unlock real innovation?
Look, the market sorts that out pretty fast. Some ideas will be trivial, sure, but making it accessible globally means useful, transformative ideas will pop up in places we wouldn't expect. The barrier's just gone.
Okay, so we've got this picture. Immense investment, custom chips, billions poured into infrastructure.
Yeah, the scale is mind-boggling.
But let's talk about the weird contrast here. All this AI boom is happening while the rest of the economy looks, a bit wobbly.
That's the tension, isn't it? AI's soaring, but other indicators are flashing warning signs. You even have top officials, like the Treasury Secretary, admitting parts of the economy, housing, manufacturing, are basically in recession.
And the job numbers back that up.
They do. Last month, 153,000 job cuts, worst October since 2003. And total layoffs this year are over 1 million already.
Over 1 million. That's only happened 5 times in the last, 30-plus years.
Right. So you've got that instability, and then you look at the S&P 500 earnings calls.
Let me guess, AI mentions are up.
Up doesn't cover it. They passed 10,000 mentions for the first time ever, doubled in just 18 months. And hundreds of billions are flowing into AI infrastructure like those Google chips we talked about.
So it feels like two different economies running in parallel.
Pretty much. And this is where it gets really interesting. James Egelhoff, the chief economist at BNP Paribas, basically said it out loud. AI has kept the economy out of a recession.
Wow, so AI isn't just a booming sector, it's acting as a counterweight, propping things up.
That seems to be the argument, which leads to the really big question for you, the listener. What if that support falters? What if AI growth slows down? Or the U.S. somehow loses its lead in dealing this stuff?
How fragile does everything else become then?
Exactly, and that risk isn't theoretical. NVIDIA's CEO, Jensen Huang, warned about this.
What was his warning?
He basically said, despite all the U.S. investment, China could still potentially win the AI race.
How? Aren't there restrictions?
His point was about lower energy costs and maybe lighter regulation over there. If training the next generation of models becomes all about cost efficiency,
Then having cheaper power could be a decisive advantage, overriding other factors.
it could be. It makes that efficiency point about Google's Axion chips even more critical. Saving energy isn't just green, it's about global competitiveness. Every bit counts.
Okay, let's pivot back to where computing meets the physical world. Robotics.
Yeah.
We started with the XPENG iron.
Right, their first female humanoid. Touch-sensitive skin, digital face with expressions. But the walk was the star?
The walk that needed the debunking video.
Hmm.
And they're planning mass production next year.
That's the plan. And seeing that kind of progress is probably why big tech is suddenly very interested in robots again.
You mean Apple? There was that Morgan Stanley report.
Yeah, calling robotics potentially Apple's next huge moneymaker after the iPhone, that's a massive statement.
What kind of numbers were they talking about?
They estimated Apple could grab like 9% of the robotics market, which by 2040 they figured could mean $133 billion in yearly revenue for Apple.
$133 billion a year, just from robots.
Crazy potential. And it's not just analyst talk. There are rumors Apple's actually working on something concrete.
What's the rumor?
A tabletop robot being developed supposedly in Vietnam, maybe for release around 2027.
Interesting. But okay, let's inject a dose of reality here.
Yeah.
We see these amazing walking robots, huge market forecasts.
Mm.
But how well do the AI brains actually handle the messy physical world?
Yeah, there's a pretty significant gap there. Recent research really highlighted this.
What do they do?
They took 6 top-tier AI models. Think Gemini 2.5 Pro, Claude Opus 4.1, they're really powerful ones.
Okay.
And they tried to get them to control simple robot vacuums, just basic commands in a real room.
How'd that go? These things can write code, pass exams. Driving a vacuum should be easy, right?
You'd think, but the results were humbling. The best models only completed the task successfully around 40% and 37% of the time.
Ouch. Less than half. What went wrong?
Basic stuff, really. Spatial reasoning was a big problem, bumping into walls, getting stuck. They'd lose track of objects they were supposed to interact with, mess up the sequence of actions.
So the intelligence we see in language doesn't easily translate to understanding and navigating physical space.
Not yet. Not reliably. It shows there's still a massive engineering challenge. The XPENG robot can walk convincingly, sure. But can it reliably navigate a cluttered room or clean up a spill without causing more problems? That's the hurdle.
That gap between digital smarts and physical competence is definitely key right now. Okay, so let's try to pull these threads together from today's dive.
Seems like 3 main themes emerged. First, the sheer scale of investment in custom AI hardware, like Google's chips. It's fundamental now.
Second, this parallel push to make AI tools accessible everywhere, like with Opal expanding globally, democratizing the tech.
And third, this sort of precarious dependence. The whole global economy seems to be riding on this AI wave continuing, acting as a buffer against recession elsewhere.
That reliance really is the core thing to chew on, isn't it?
I think so. If custom silicon and these massive investments are indeed keeping parts of the economy afloat,
Then you have to ask, how vulnerable does that make, say, the U.S. economy if competitors gain an edge? Like Jensen Huang warned, if someone else figures out how to do this foundational AI cheaper, maybe due to lower energy costs.
what happens then? It means the race for better AI chips isn't just about tech leadership, it's potentially about macroeconomic stability.
A lot to think about there.
Definitely. We hope this deep dive gave you some useful insights.
Please do follow us and share this with others who might find it valuable.
Thanks for joining us on AI Brief. We'll catch you next time.